Hello, everybody. My name is SachinMathur, and I will be presenting a case study in clinical trials. Drug companies, before they bring a drug to the market, they want to find out if the drug is working or not. So if they have a specific indication like Alzheimer's, they want to first test the drug in some Alzheimer's patients, see if it is working or not, and then market the drug. So when they select the Alzheimer's patients, they want to have patients who have the disease and not really have patients who do not have the disease. So they define certain criteria for selecting patients, and these are called the eligibility criteria. So they consist of two parts, the inclusion criteria and the exclusion criteria. Inclusion criteria are the desired patient characteristics, and the exclusion criteria are the undesired characteristics. These eligibility criteria have to be carefully selected because if these are not selected well, then there could be, first of all, detrimental to the patient health. Secondly, there could be cost escalations and delays. So the problem here is to come up with a specific eligibility criteria, and once the eligibility criteria are selected, you want to make sure that these are specific to a particular disease. So the use case I've chosen over here is for breast cancer and Alzheimer's. Suppose a clinical trial is being designed for breast cancer and eligibility criteria have been written. The model can be used to find out if the eligibility criteria is specific to either breast cancer in comparison with Alzheimer's. I've used RStudio to extract the data, and some of the packages are PostgreSQL, which is to connect to the database, StringR and TidyR are NLP libraries, and dplyr is something like pandas or panda functions in R. To get the data, an account has to be created at AACT. This is a website and the account is free. The second half of the project is using Jupyter with Python 3.6. So the packages are NLTK, Keras, Pandas, and Gensim. I've used GitHub to deposit all of my work in the repository. I've used RStudio on the Windows PC environment, and the Python was run on Google Collaboratory. The backend was a GPU. The data set consists of three parts. The first one is data for word embedding. So this is eligibility criteria from clinical trials. For 12,000 were randomly selected, and this consisted of all kinds of different diseases. And these were all extracted through using RStudio, connecting R with an API from AACT. The second set consisted of about 500 clinical trials belonging to breast cancer and Alzheimer's, and all of these 500 clinical trials were part of the word embedding. The third consisted of about 200 trials belonging to breast cancer and Alzheimer's, and these were not part of the word embedding, the data set used for word embedding. All of this data is found in GitHub, and the location for the AACT clinical trials is listed below the link of GitHub. So in all, about 160,000 sentences were used for word embedding, and this is about 21 MB of data. And I've put in about a sample data set for submission, which consists of about 70,000 lines or 70,000 sentences. There were about 2,500 training samples or training sentences and 608 test samples. So to run this these algorithms, you need to first install the RStudio on the PC or on Linux. It doesn't really matter. Sign up for an account for AACT. Use R to extract data from AACT API. The code is already there. The next part is to clean the inclusion-exclusion criteria, and then get an account in Google, and so that you can use Google Colab. Install NLTK, Gensim, and in the Google Colab, upload all of these data files, the data files that you get from the R code into the Google Drive. Perform NLP on the word embedding text, create the word embedding, and then create the models, train them using the training data, and then measure the performance on the test data. So after extraction, the data was cleaned by removing new lines, and the number of criteria were extracted. So here is an example of the raw text, which you see as a single blob. And this has to be kind of delineated into different criteria. For example, there are multiple criteria in this sentence, in this blob, and so they have to be kind of extracted. So this is done in the RStudio. Further NLP included converting it into lower text, removing numeric and alphanumeric characters, and then removing extra spaces, keeping words of only at least 3 characters or at least 4 characters long, tokenizing, and then keeping tokens that were found in at least, that had a frequency of occurrence of at least 5 in the corpus. Here is an example of the text, which is from the RStudio, and then this is all the NLP done in Python. For word embedding, once the text is consistent, this was skipgram was used for creating a word embedding, and skipgram is part of the Gensim Python package. The vocabulary size was about 3,438 tokens, and the dimensions were 100. Here is an example of the word similar to diagnosis. So all of these thrombocythemia, promilac, cytic, and myeloproliferative are kind of similar to diagnosis. Here is an example of the word vector for diagnosis. It is 100-dimension vector. And this is a visualization of the word embedding. So terms that were similar to diagnosis. So here, anti-inflammatory, methadone, immunosuppressive. These are drugs which have an anti-inflammatory function. So they're kind of clustered together. So by looking at this word embedding, you can find out whether word embedding is good or bad. The code overview, all of this data, all of the code has been clearly delineated. For example, importing the data, text processing, then word embedding, reading the data, vectorizing the training and test data, a model creation, and then the evaluation. For the model development, I have used a simple RNN, an LSTM, and a bidirectional LSTM. I've also created a one-hot encoding model to serve as a baseline and compare it with the word embeddings. We used callback functions such as early stopping and ran the model for about 50 epochs. And using the training set, I carved out a validation set to get an assessment on the assessment of the algorithm on the validation set. Here are the results for the training and validation accuracy for the bidirectional LSTM and the LSTM. The validation and the training accuracy seem to go hand in hand. So it's not much of overfitting here. and the accuracy is about 98% in both. In the simple RNN, it's the same story. In fact, the validation accuracy is slightly higher than the training set, or they're very similar to each other. There is slightly, it's a little weird in the one-hot encoding, where the word embedding was not used. And this is the final result. When no embedding was used, the accuracy is about 89-90%. When word embedding is used, the minimum accuracy is about 92%, so there is an increase of 2%. But depending on which kind of model, whether it's bidirectional or simple RNN or LSTM, the accuracy increases to about 93.5%. So there is roughly 4% gain in accuracy by using LSTM in conjunction with word embedding. So in terms of lessons learned, it is important to clean up text before creating a word embedding. I've tried out stemming and lemmatization, but they made the word embedding worse. One way to check word embedding is to just visualize it and kind of obtains words similar to a given word. And if you find that they make sense, that means the word embedding is okay. I tried running word embedding on my PC and it just went on and on. So it's better to use a GPU, and this one took maybe 5-10 minutes on the GPU. The LSTM in conjunction with the word embedding were able to achieve higher accuracy, about 93.5%, and using one-hot encoding is about 80-89%. The future work is to extend this to other indications such as fatty liver. I've created a model for the inclusion criteria, but a similar model can be made for exclusion criteria. It's important to find the reasons for misclassifications and see if the model can be fine-tuned. Experiment with other word embedding such as glove, fast text. Fast text seems to be quite promising. And there is one of the problems of word inflections. So maybe use stemming or lemmatization in a limited setting. And here is the URL for the 2-minute short video, and then I will be posting the 15 minutes long video as well. Thank you for your time.